Assalamualaikum warahmatullahi wabarakatuh. To Dr. Farina, our lecturer. My name is Ifan Daris bin Muhammad Ibrahim, matrix number AE170139. And today, our group, me and Nur Hafizah binti Ibrahim, will present optical beam induced resistance changes or BIRCH. And our slide content of introduction, characterization and technique and analysis, advantage and disadvantage, methodology, discussion and conclusion.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hafizah binti Ibrahim. My metric number is CE170062. I would like to explain my part. My part is characterization, technique and analysis, advantage and disadvantage for this technique, also conclusion.
Assalamualaikum warahmatullahi wabarakatuh to our lecturer Dr. Farina. And now I will present about optical beam induces resistance change, or I call OBERG. Okay. What is OBERG is? Okay, OBERG is one of the technique for thermal laser stimulation. Thermal laser stimulation is a class of defect imaging technique which employ a laser to produce a thermal variation in semiconductor device. This technique used for semiconductor failure analysis. Okay, so for example, if we want to detect a semiconductor IC semiconductor, we can use thermal laser stimulation or in specific OBERG. Okay, thermal laser stimulation have 4 technique. One of them is OBERG, and another 3 is is induced resistance change. Thermally induced voltage alteration (TIVA), external induced voltage alteration, and seeback imaging. But now I will focus on OBERG lah. Okay. We now take a look in this picture. In this picture is how OBERG is used to detect a defect. Okay, so laser stimulation highlight differences in thermal characteristic between areas containing defect and areas which are defect free. It's mean that in this area, if they have different thermal characteristic, it can differentiate between defect or defect free. Okay, as the laser locally hits a defective area which carrying a current, so the result resistance change can be detected by monitoring the input current to the device. Okay, after we detect the defect one, the resistance changes. Okay, the resistance changes, and we can take a look at the monitor for the input current of the device. And OBERG is also useful for detecting electromigration effect resulting in open metal lines. Okay.
The characterization, technique and analysis for optical beam induced resistance change, or BIRCH, is the partial resolution is between 1.0 to 1.5 micrometer. For the minimum power in 1 hour average is 10 microwatt per second. The resolution temperature is doesn't measure device operating temperature. For the resolution, full frame time is higher than 100 millisecond. The sample temperature, it can be a wide range. The small resistance change may be missed for this technique. The advantage of OBIRCH is superior to thermal wave from the viewpoint of data acquisition speed, which is 7,200 times faster by OBIRCH than by thermal wave. The second advantage is ability to detect silicon nodules. For the disadvantage, this technique is the signal of OBIRCH is not stronger than the OBIC signal at actual device in OBIRC system.
Okay, for methodology, now we look how Obersh is being used, how the process is. So, for the first part, an area of interest is selected on the device, and a laser beam is used to scan the area. The input current being drawn by the device is monitored for the changes during this process. Okay, the statement means an area of interest. For example, just now, semiconductor. So semiconductor is an area of interest. Okay, on the device, and laser beam is used to scan the area. The scan or the body of the semiconductor scan the area, and the input current being drawn by the device is monitored for changes during this process. Okay. For the next part, when a change in current is noted, the position of the laser at the time that change occurred is marked. As just now, we have the red box right at the picture. So when a change in current, so it will have a mark on the image of the device. Okay. For the next step, the laser beam strikes a location which does not contain a void. Good thermal transmission exists, and the change in electrical resistance is small. Okay. If the area of interest does not contain a void or defect, good thermal transmission exists, and the change in electrical resistance is small. But if area containing voids, thermal transmission is impeded, resulting in a larger change in resistance. Okay, if the contains voids, the thermal transmission is impeded, resulting in larger change in resistance. Okay, for the last part, the degree of resistance change is displayed visually on an image of the device. Okay, if the resistance change, whether the display is visually on image. So for the red box, like what I explained just now, if they have a difference in resistance, so it will visually display on the image of area and of interest. And it also with area of higher resistance being displayed as a bright spot. Higher resistance will display as bright spot, and resistance change also visually on an image. That's all. And now we can take a look for discussion what we can discuss for Oberge. Oberge is not for semiconductor failure analysis, but Oberge is an indispensable failure analysis tool in semiconductor industry. It is useful not only for test structure but for final products. And it's also useful for field failures and the failure in manufacturing process at development phase and mass production phase. Okay. Next, Oberge is a very powerful fault localization technique for IC, and this is a type of Oberge that can detect or investigate defects. For example, short in polysilicon, gate oxide pinhole, void in metal tracks and plugs, high resistance underneath, drain and source shorts, and detect FEOL and BEOL. FEOL is a front end offline, and BEOL is back end offline connection. Okay, and the types of ray that Oberge is used, one of it is IR Oberge, which is infrared Oberge. This IR Oberge can detect defects and current path for the backside of silicon. Because of what? Because of small attenuation. 1.3 micrometer wavelength laser in silicons. So infrared can detect the defects because of small wavelength. For the future application of the obverge, two different approaches are promising, which is specifically designed test structure and solid immersion lens. Okay. That was for discussion. Thank you.
In conclusion, OBIRCH has shown as a suitable instrument for failure and weakness detection on power semiconductors, where usually EMMI is impossible due to thick metal layers and high doping concentrations of the silicon. Since the current sensitivity of this method is of outstanding performance, OBIRCH doesn't detect the main leakage path only, but additional or potential bypass paths or weakness too. Those physical analysis may even be possible in those cases where the main leakage path doesn't allow further physical conclusions due to the critical structures being melted.